Technology is changing the way we look at the world and the way we do business globally. Joining us now on stage is the design director from the Blue House Group, Tony Archibold, to share some of his insights. Please welcome Tony.
So what I'm going to be talking about today is really our experience of BIM. We are probably atypical to the normal kind of use case, so I'll explain what I mean by that. Essentially, we're a boutique design firm. We offer architecture, interior design, and mechanical, electrical, plumbing engineering. And we do all of this in-house. So really our approach has been to own as much of the design information as possible and really to see how far we can take that. What are the limits of the tool set? What are the value adds that we can offer to our normal deliverables? And that's really what I'm going to talk you through now. So essentially, I guess we've been using BIM for around 2 years. My personal background is that I have been using Revit before it was actually purchased by Autodesk in version 1, which I think was around 2003 or thereabouts. So I guess I'm a kind of an early adopter by nature, and I've kind of followed that really in terms of the way that we're using these tools at Blue House. So this screen is really a snapshot of some of the projects that we've delivered over the last couple of years. So we have a kind of a mandate, which is almost a kind of ideology, I guess you'd say, that we do everything in 3D. We don't use 2D CAD for anything. Actually, I think we've got one project which is a special case, but everything is done in 3D. And predominantly, I guess, our background has been in interiors. Now, this is really a discipline that doesn't use Revit or BIM at all. And so we've really tried to look in a kind of smarter working kind of way at how we can leverage this tool to deliver more value. So on this slide you can see in front of you, we've got a kind of snapshot of a number of projects. I'm not going to go through all of these, but there's a couple of ones that I'd like to kind of highlight. We've got the Morass Dome, which we're doing as part of the City Walk area. This is on site at the moment. And this is basically, it's a 4D cinema with a hemispherical projection surfaces and completely isolated domes. We've got two concentric domes, which I'll show you briefly in a moment. And all of that, we've modeled everything from the ground up, essentially, including all of the MEP. Another project which you may have seen fairly recently is Pier Chic, which we've done for the Jumeirah Group. This was 2 pods that we dropped into the sea on piles on a steel frame, and one is a bar and one is a lounge, which are extensions to the Pier Chic restaurant, which is also recently refurbished by another consultant. So this is live. You can go and look at this. So I guess really a part of our challenge is really the journey from a digital conception into the physical and back again, and that's really the topic of this talk. Okay, now, in terms of what BIM offers, I'm sure you're all very familiar with some of the advantages. I guess because we're doing this in-house, we've been able to leverage this a lot. So essentially, we're working from the very small component level, really, which is a kind of an interior design related focus, really through every single aspect. So we have, over the last 2 years, built libraries of components that we've designed with fully integrated, for example, pantry units with all of the joinery, all of the power supplies, plumbing, drainage, wet services, and these are families that we've built as part of our own kind of intellectual property that we can then hone and deploy on future projects. So we have what we call the 80-20 rule, and that really goes along the lines of taking 80% of the models we've already built and being able to reuse those because they're known, they're tested, and they're very reliable. And that buys us enough time to spend 20% of pure blue sky innovation for every single job we do. And that's our kind of benchmark. And the beauty of this approach is that 20% can then get fed back into the next project as part of the 80%. So we're growing, we're learning as we go. Okay, this is a project we've done for Weatherford. I'll give you a little bit more detail on this. It's an interior design project. And this is just kind of a snapshot of what happens when you're overlaying all of the mechanical services and the layouts, furniture, floor boxes, partition systems, security systems, AV systems all on one drawing. It's pretty impenetrable. This is what you're reduced to if you end up trying to do it in CAD, assuming you're even drawing all these ducts in the first place. Now, this example is the Morass Dome. I'm going to show you a couple of slides here. This is important because instead of looking at the kind of the 2D view, we're looking at the component level with actual manufacturers' models that we've built. So typically, there are Revit families out there. Some are better than others, so there's a quality issue generally. And in many cases, you really only get CAD blocks. And so where we've used suppliers on a repeated basis, we model those from scratch and use them. And this comes back to what I was saying about the 80% rule. All these library components actually add a lot of value over time. And it's something that really, I don't think is really touched on in the way that people understand the BIM design process. The fact that if you can make it a learning process, then the value that gets added to the project successively increments over time, which is a great USP. So what you're looking at here is basically the dome, which I mentioned earlier, combined with the mechanical ventilation drawings, and some of the camera positions, firefighting equipment overlaid so that we can then run clash detections on those. This then can also be then stepped up to look at how those elements integrate within the structural envelope, and also the facade element, the cladding and the glazing systems, and how they integrate and how they're viewed from outside. On this project, we've also got very tight constraints in terms of acoustic performance. So the inside dome, which is what you're looking at here, has a small access way, which you can see. There's a kind of a small lip that you can see running around the dome. This is a gantry way. And the inside dome is completely isolated from the outside dome. Separate structure, acoustically sealed, light sealed, black box. And so this was really a challenge to make sure that we manage the interactions and the penetrations through those envelopes to get air inside and to keep the sound inside the dome. And here you can see what would be kind of more comprehensible, I guess, in terms of an image. This is with the outside dome laid over the top, which is basically is an aluminium panel system with a very thin shadow gap detail. So you get this sense of a panel that is sufficiently tessellated to give you a nice sense of curvature. We also have a gimbaled lighting system that turns this whole sphere into a ball of color that can be programmed. So we can dial the color into this. And the idea conceptually behind this is you've got a box, which is a container. The area, I don't know if you know the area really, on that Morass development, it's got this kind of graffiti-styled hoarding. It's called the container park. It's a series of boxes. And so our idea was that this would be a jewel, this kind of glowing orb with an event inside it that sits inside the box. And this is really the kind of the plumbing for that, I guess you'd say. And as I think some of our earlier speakers touched on, we're able to cut sections and view elements of these assemblies, and more importantly, explain them to the client so they can understand and that this has been fully tested and validated. And we're also able to assist the contractor to make sure that when they're casting the ring wall for the base structure of the inside dome, that we've got all those openings exactly located, and they have full confidence that as we build out the structure, that all of those MEP shafts and other conduits are going to go in as programmed and as designed. I mentioned that we do a lot of interiors work. This is kind of a little sectional model I've put together just to show you, again, how it looks in 3D. We cut a lot of these. We do internal peer review sessions internally within Blue House so that our engineers, lighting designers, FF&E guys, interior designers can sit down and work out not only how something works, but also how it looks. That kind of coordination, that deep coordination within the team to make sure that this space is as clean and as uncluttered, and that the noise is reduced to an absolute minimum in terms of its visual appearance. And that same model then also gets exported into our visualization software, so we're using Max for visuals. We also do real-time visualizations where we're using kind of game engine technology, drop the same geometry in, and then we can actually do walkthroughs in real time with the client, which they're not really expecting and which they're generally pretty delighted about. In terms of what this means, I guess one of the key things really is that, coming from primarily the corporate market, I guess you'd say, with interiors, a lot of our corporate blue chips really demand a very demonstrable level of accuracy in terms of the performance of the spaces. So what I'm talking about here is things like lighting levels, temperature levels, acoustic levels, and we actually model those in-house. So this is an example for Boston Consulting Group, which we're currently building in Riyadh. So we've got the HVAC layout. You can also see at the back here there's a small breakout space, and we've got kind of a pantry unit with all of the plumbing integrated for that, which I've explained earlier is a little pre-built model that we have. We have an AV unit and an AV system, which then goes back up to a main server. You can see the firefighting as well. This is that same model with its clothes on. So here you can see we've got these kind of floating lights in the center of the space, and we've got a sense of where the finishes sit in relation to the skeleton and the kind of plumbing. And then this steps forward into our lighting simulator, where we're using the actual IES profiles of the luminaires from the manufacturer to simulate the actual light in that space. So this is like all the other lights turned off, and you've got the 4 floating lights in the center, and this is the lighting effect that you get from that. We can also output the same data as a contour map, so we can show the lumen count, the lux levels, for every single surface as a contour with sort of 600, 500, 400, and that automatically allows the client ease of mind, in a sense, that they're getting the right levels of illuminance onto their work surfaces. And again, this is another variant. So we tried different luminaires, and you can see the kind of the effect on the lighting and the mood. This is just a quick section in terms of kind of head heights. What we often find is that we tend to go into buildings that they're already shell and core. So these are fit-out situations on a base build. One of the key challenges there is to make sure that we're making best use of what's already been installed. So very often you'll have the main HVAC ducts into the space. You'll have existing firefighting. Now, if you're going to plan an interior into that space, you need to know where all that stuff is. And this is what I'm going to come on to next, is how we can basically know with great precision where that stuff is, and then we can design our system to fit into it, rather than assuming that you're going to strip it all out and start again, which is widely done in the industry. The other thing we can do, which as again you're all familiar with, having put this information into a single model, we can also get it out in a variety of ways. Now, one of the advantages with this, obviously in terms of CAD drawings, is very well known, but we actually get a lot of value out of the schedules that we can pull out. So we can pull out door schedules, room schedules, populate automatic room data sheets, and these numbers are all zero error, because they're actually machine calculated. So this gives us a great base to work from. It allows us to test our designs and to demonstrate things like floor area efficiency and other criteria. It also means that we can pull out fairly detailed BOQs to give to project managers that we're working with to allow them certainty in terms of the quantification. And then they simply need to add a unit rate to then develop a very detailed cost plan. And all of this stuff is really happening much earlier in the design cycle. So typically, a detailed cost plan only happens at detailed design, which is kind of logical. We do all of our heavy lifting now in schematics. So our schematic design stage involves a lot more heavy lifting, but it also means that we can quantify accurately the cost for a project at that stage in conjunction with the QS. So this is a new capability, and it's important because the VE cycle can take place at schematic design when there's no contractor appointed. So there's no cost. The biggest cost with value engineering, typically when it takes place at detailed design, or worse, post-tender, is that you have the on-cost of the contractor who's then submitting variations. So these are just some simple examples. Okay, really the headline of the talk was really around the idea of physical to virtual and back again. And really, I think the next thing I really wanted to touch on, which is really the second part of this talk, is where do we get the data from? You know, typically when you get as-built drawings, there are a set of design drawings from at some point, preferably detailed design, where the building has not been built. It will not reflect the actual conditions constructed on site. And it's a major problem, and it's a major piece of risk, both for us as consultants when we do our design, but also for our clients who want to make sure that whatever we're going to design is going to fit exactly into that space or into that location. So we recently did some research. I say recently, this is around 12, 13 months ago, into how we can acquire that data. Research really kind of pointed out some developments that have been with the oil and gas industry for a while, and we purchased our own 3D laser scanner in-house. We use that scanner to develop completely detailed models of any space that we put a building or an interior into. So our scanner basically develops, it has a 360-meter diameter, a ball that it can survey, and it surveys every surface that it can see in a line of sight to plus or minus 2 millimeters of accuracy, which is pretty phenomenal. It's so good that we can look at the underside of a slab, we can give you a contour map as to how flat it is, or the floor. So these are very useful when, for example, calculating deflection head sizes for partitions. We know exactly what the variance is in the slab, and sometimes it can be considerable, and sometimes it can even be shocking in terms of the quality control that's taken place on any given site. So what you're looking at here is the Weatherford project that I mentioned. It's a fairly simple project, fairly small one single floor, one tenant that we were designing for. You can see the white circles. These are the survey points where we moved our tripod and did the scans from. So we've got basically 6 points for the open plan area. And this captures all of the sprinkler heads, it captures all of the mullions, every single surface is mapped. And then we can also capture a JPEG image as we do the scan, so we can map this texture onto that surface, which makes it much more easy to read. And this is really those two things combined into one image. The next thing we do from this data, which is a very large file, it might run to 100 gigs of data, is to make it usable. You can't drop that into Revit, at least without it falling on its back dead. So what we do then is we post-process that information, and we produce vector-based information from it. In other words, we're replacing pieces of flat welded surface with Revit parts and Revit families that we have in-house. So here you can see the Revit model of that laser scan exactly. Now clearly there are decisions to be made within this. It's not automatic. It's close, but it's not quite automatic. We need to look at the fitness line. So for example, when you're putting in a flat floor plane, in Revit it is flat, 100% flat. The as-built will not be 100% flat. So you end up basically determining the top of a SSL, structural slab level, and the fitting ratio of where you decide to construct that plane needs to conform with the kind of the standard deviation of where the floor actually sits. So that plus or minus 2 mils of accuracy in the laser scan comes in very handy at that point. This looks like a standard photo. This is actually the standard photo that you might expect, taken by the laser scanner, plus all of the laser scan data. And at the end of this presentation, I'm going to show you this as a 3D view. So you can see here, this is a kind of typical case for us of what we might expect to go into on an interiors project. And all of this data is replaced by Revit families and objects, which means if we want to extend firefighting runs, we can tap into the existing and thereby save the abortive cost of ripping all that stuff out, as I mentioned earlier. We can also take viewpoints that aren't accessible by camera. So obviously, if you're taking shots of a site, they're kind of eye level or within the human ergonomic range. We can look above the ceiling, we can flip the model upside down, we can get into spaces that are not accessible by people, but you can get the laser scanning head up into. And then we can also start to build that out. So this is just a quick screenshot of the JPEG bitmap data overlaid with the laser geometry. Sometimes we also have interiors that are partially fitted out. Now this does present problems. It's one of our challenges in the sense that obviously glass refracts light. And here you can see we've got some existing glazed partitions. So this is a second process where we need to sort of take out some of that bad geometry. The laser will often hit the glass surface and rebound, causing errors in terms of the way that it picks up information. But now we're pretty good at that, and we take special care in terms of the sighting of the laser scanning head, and we take multiple views to be able to cancel that error out. The other thing that's quite interesting about this also is that in jobs where there isn't a facade, you also have to be a bit careful. We've just done a scan for Jumeirah Group's new headquarters down at D3, and we the facade wasn't on when we did the scan. So we did the scans of the interior, and it picked up not only Jumeirah Group's headquarters, but 3 buildings out, and the crane, and all the site works. So we were then obliged to step that back and pull that information off, because it automatically goes out to 360 meters of diameter. Sometimes the visual images can be a little bit messy. We have here a scan that was done while the client was in the room, and you can see the client has actually been scanned. They're in there as well. So we have to obviously eliminate some of that noise, but it's a very simple and quick process. And from that, you're able to take out those troublesome partitions and the other noise and get back to a clean Revit model. Here, obviously that looks quite simple. You can see the existing floor trunking which we left in, because that was a key piece of information from us. And then this is what happens when we started dropping in our Revit components. You can see also that we model all of the furniture components. We work with almost all the furniture suppliers, but that's a fairly limited subset of data. So it's progressively, if we come across a new supplier, we'll use their product libraries, which, as I said, are very often AutoCAD libraries, and then we'll build our Revit families from that. So we can actually drop in models that correspond exactly to the workstation that's being used. So for example, if it has the screen, the kind of screen that's being used will be updated, and the type of chair, the type of leg. So what they're looking at is a very close simulation of the interior that they're getting. And then we can go upstairs and work in the MEP components around that. And then we can start looking at ceiling grids, cove lighting, and then how that renders. That's not a photograph, that's worked directly from the same IES profiles with all of the FF&E and acoustic panels in the project for that same client. So you can see here the progression. Very quickly a model that is simple, the inception of the project becomes quite complex and becomes quite layered. So again, for having cut down our 100 gig laser file down to a 1 or 2 meg Revit file, that library then gets built back up again as we start to add in lots of geometry and components. And again, with this, I think it's important to note another reason not to use libraries that come from third parties is where you've got a chair, it might have been modeled in Max and then brought into Revit, and then it's called a Revit model. That just doesn't work. You've got thousands of tessellations, loads of extraneous geometry, and if you try and work with that, then your whole system resources call to a halt. So it is definitely necessary to build your own libraries from scratch. And as I say, the idea of learning lessens that pain. So obviously the first few projects that we did a couple of years back were more painful. We had to put more resource onto projects in order to get our libraries started, and that pain is going on still a little bit, but I think we're probably almost at the end of that process, which is at the end of a 24-month kind of digital build-out cycle, I guess you'd say. And again, when you start looking at the kind of the macro pictures, you can see how the HVAC is working, how that relates to diffusers, so we can output exact diffuser counts. Again, that goes into the BOQs. We can overlay the MEP directly onto the furniture layouts, and we also take it all the way down the line and do all of our detailing. So I'm pretty sure we may well be the only people doing this end to end, in the sense that very valuable ability to cut a section means that when you're drawing a detail of that section and annotating it, that you're working off a live cut. So if there's an update to the model as a result of a client change, then we can then reflect that in those details and capture that. So the ability to capture change is very, very useful. Had we had that requirement to do that in traditional CAD, it would be abortive in terms of the effort involved. And it also means we're able to explain our designs in great detail. So contractors like this. There's no equivocation. It's basically our drawings say what it says on the tin, and the contractor needs to follow that. And we're quite tough on the contractors. We think it helps the contractors because they're able to visualize, from the drawings that we issue. So we also issue isometric views as part of our drawing sets, just so even if it doesn't have dimensions on it, still helps in terms of the kind of the coherence of the design, in an effort to make it easier for the client, for the contractor to see the assembly at the top level. Very often, if you're just reverting to a set of 2D drawing outputs, even if they're generated by Revit, it's still hard for a contractor to understand what that assembly, that final assembly looks like. And that's why we produce these drawings. So essentially, this is a new drawing type we didn't used to do 3 years ago. And we do this as a standard matter of course to help the contractor and therefore kind of minimize misunderstandings, I guess you'd say. We also, in terms of the schematic design process, I mentioned that we do a lot of our heavy lifting early on. There are dangers with that too. If a client is exposed to a full 3D model at schematic design, then very often you can get into that conversation you don't want to have, which is, where's my office? What's the color of my chair? So we obviate that by introducing a new kind of component to the schematic design, which is white modeling. As a matter of course, we will get a white model signed off and approved before we get sign off on the finishes. And this is really to allow the client to understand how the space works, where stuff's going, ergonomics, lighting, and then finishes come as a second step. So this is a grayscale model with accurate daylighting applied to it so that they can then understand how their space works prior to us getting involved with finishes, colors, and other components. Okay, so I'm just going to, I mentioned I was going to show you a quick animation. I'll do that just now. I think it's useful to get a sense. This is a project that we're doing with the Tulip group now. It's a 3D scan, raw, and we've just done a quick fly-through so you can get a sense of the fact that the JPEG is mapped onto the 3D, but the level of detail that we get from those scans. It's picked up the escalators, lift housings, even the cables inside those lift housings are captured. Anyone who was in the space at the time, light fittings, sprinkler heads, and this is on a fairly big floor plate. Now we had a 4-man team. We did the survey in 2 days. Post-processing was 4 days. So that's pretty cost efficient in terms of a client because they've got a full as-built set of drawings with absolutely everything on it, and that's post-processed into a BIM model that they can then use.